Today we're looking at note 7.6, log properties, and for today we're just doing expanding. Okay, so these are three properties that you should write down, three log properties that we will be looking at. So the product property states that if you've got a log base b of m times n, that can expand to log base b of m plus log base b of n. The quotient property states that if you've got log base b of m divided by n, then that can expand to log base b of m minus log base b of n. Last but not least, the power property states that log base b of m raised to the k power is the same thing as k times log base b of m. So let's look at a couple of examples using these properties. So if I ask you to expand log base 3 of x times y, since those are being multiplied, I'm going to use the product property. The product property states that I can expand this by saying that log base 3 of my first letter here, so x, plus in between log base 3 of y. Okay. Looking at example number 2, this is now going to be the quotient property because I'm dividing, and this property states that I can take this log base 2 of 7 divided by 3, and it is equal to log base 2 of 7. In this case, it's minus log base 2 of what's in the denominator, so 3. Okay, and last but not least, to use my power property, I have log base 4 of x raised to the third power, which is the same thing as when I take that power, put it out in front, so 3 log base 4 of x. So those are some basic examples. Let's get into some that combine some steps. So if I've got log base 3 of p squared divided by q, I'm first going to use my quotient property because I'm dividing here. And my quotient property states that that would equal log base 3 of p squared, remember what's on the numerator, minus log base 3 of q, what's on the denominator. So here I've taken my quotient property and used it for what we were dividing, but now I've got this exponent. So if you have something like this, don't forget to pull powers down last. Okay, so my last step is to take that power and use the power property and pull it down. So this equals 2 log base 3 of p minus log base 3 of q. That's my final step on that one. Okay, let's look at another example. If I have log, remember that's base 10, of 4 divided by ab squared, then by my quotient property, this is log base 10 of 4 minus, I have to be careful on this one, log base 10 of a and another minus. So this is kind of a key point here. Anything in denominator gets a subtraction sign, okay? So that's kind of a key point there. So since the b squared is in the denominator, this would be minus log base 10 of b squared. And remember, my last step is to not forget to pull powers down. So this equals log 4 minus log a minus, pull that power down to the front, 2 log b. So now I have my final answer. Okay, let's look at just a few more. So on number 6, when I expand, this would be log base 4 of 3, and on the top here, I can expand that even further to log base 4 x, okay? And then remember, anything on the denominator gets a minus, so log base 4 of 2 minus log base 4 of y. And I don't have any powers to bring down, so that's my final answer on that one. Okay, looking at this guy, okay, what I have here is, remember that when I have a number in front of parentheses, that means times. So I'm going to use my product property and say that this is the same as log 4 plus, because they're being multiplied, log x plus 2 squared. And my last step here, I can't do anything further with this because that's being added and not multiplied, so I can't tear that apart anymore, but I can take down my power of 2. So that becomes 2 log base 10 of x plus 2. That's my final step on that one. All right, so looking at this next one, it's definitely different from the one above. So on this one above, I had a square, but this is a binomial, okay? I would have had to do FOIL to square that. Here, our properties of exponents are, this is not a binomial, this is a monomial. That 2 goes to everything inside. So let's look at how this is going to look. We are going to have, for this one, log base 7 of 5 squared plus log base 7 of x squared plus log base 7 of y squared, because that 2 distributes inside to every single one of those. And then on the bottom, we've got minus log base 7 of 3 minus log base 7 of, that's a z. Okay. And now last but not least, we need to drag all of the powers down. So I'm actually probably going to need more space. So that would be 2 log base 7 of 5 plus 2 log base 7 of x plus 2 log base 7 of y minus log base 7 of 3 minus log base 7 of z. And that would be our final answer.